This is a presentation of the final project in EMB1 at SDU, and what we're doing in this project is that we are heating some water to a given set point or temperature, and we're using a 12 volt coffee cup heater used in a car, and the given set point or mounted temperature is given by the end user on a C# program here, which will start. And here we're connecting to the FPGA. We have virtual serial port to the FPGA's tostnet, and here we're connecting. And now we can see that it's 32 degrees, and we're giving it a set point of 34 degrees. Now it will start to heat, and while it's reaching its set point, I will explain what we are actually doing. We are using a NTC 100K thermistor, and down here we are using a 22 nanofarad capacitor. What we are doing is that we are actually counting how long it takes to load the capacitor up to 1.4, which is what FPGA will register as logic 1. And what we're doing is that on the output pin, when it goes high, we are actually charging the capacitor, and we are charging the capacitor at 1/4 of the 50 MHz internal clock, and 3/4 of the rest of the cycle we are uncharging, decharging the capacitor. And basically we're just counting number of clock cycles till we get an input of 1 on the input pin. And now we actually see that it reached the set point of the required temperature, 54, and we can see it finished here down by this. And we also have implemented another method where we can keep warm, so I will on the dip switch here. And now I've inserted the keep warm mode, and we can see over here on the laptop, if you can see it, now it says keep warm mode here, and the wanted temperature is 54 and 34, sorry, and 34 down here. It basically just checks what temperature is the water now, and then we'll keep it at that. If we go back here, what we can see now is that I will just turn off the dip switch, and then set a low set point here, so it won't disturb us. But now here, if we look at the curve on the scope here, I've set it at 1.4 volts here, and we see that it takes, at the current resistance of the thermistor, it takes 680 microseconds to charge to 1.4. And if I try and go in here, we can see how it discharges. We have the 1/4 of a cycle here, and this is the first quarter, and then we have, of course, the 3/4 out here, just over here. And here you can see that the capacitor has a lot of time to reach 0 again, so this all looks good. And of course, whenever the temperature rises of the water, the resistance in the thermistor falls, and then of course we will reach faster the 1.4 logic. We are then doing some calculations to convert the timing to an actual temperature, we put the count of the time it takes, number of cycles it takes to reach the 1.4, and we read that on the C# program, and we use the temp resistance specifications of the NTC in the program in a approximating function to calculate the temperature, and we display that for the user. And also when we want the user to input a set point, we do the all way around. We take the temperature and calculate what time would this convey in when so the FPGA can understand it. And then basically we have a wanted temperature and a current temperature, and the difference between them are used to drive the PWM signal. And the more difference there is, the more PWM we have to the transistor, and the more current it will give to the heating cup. Yeah.